This section talks about something called direct variation. And this will be one of the quickest sections of the school year for us because it's definitely worth mentioning and worth seeing, but it's not a topic I'm going to spend a great deal of time on. The biggest phrase you're going to have to watch out for is when you hear something like y varies directly with x. That phrase varies directly kind of tips you off that we're dealing with direct variation. So y varies directly with x means the equation is y equals k times x, just like that. K is some random number. We can figure it out maybe it's unknown, maybe we can get it, but it's called the constant of variation. So notice in this equation, it's a number times x, and there is going to be this is a linear equation. It's a number times x. It's going to make a line. Notice, though, that there's no number over here. I'll come back to that in a second, but let's do the second one. If it was j varies directly with q, the way you would write that as an equation is j equals k times q. The one that varies directly is by itself, and then the other two right here are being multiplied. That's just kind of a side note on that one. The one I really care about, though, is this first one here. So when we're looking at the equation, y equals k times x. Two things to note right here. So two important points. First of all, like I kind of started saying before I did the second example here, there is no y-intercepts. Or in other words, your y-intercept is 0. There's no number being added on this graph right here. It's just going to be regular plain like that. The second feature is kind of related to this. Your graph, it's a linear graph that passes through the origin. So linear graph that passes through the origin. So, if you think about this right here, y equals k times x, examples of that could be things like y equals 2x, y equals negative 7x, y equals 1/4 x. All of these graphs are direct variation. You can think about them here, all as having a little plus 0 on the end. There's no number being added or subtracted there. Well, if you graph something like 2x plus 0, you're going to start at 0 and go up 2 over 1. If it's negative 7x plus 0, you're going to go down 7 over 1. So if you're looking at a graph, the way you can tell it's direct variation is if it goes through the origin. That's kind of the big thing there. So I want to wrap up this section with just one practice problem. If you're given some information like right here, let's say we know y varies directly with x, and they give us a point on the graph. We want to figure out the constant of variation, or in other words, we want to find k. So we know what we can plug in for x and y. It's direct variation. It's going to be y equals k times x. We know an x, we know a y, we can plug them in. We get 8 equals k times 6. And solving for k, we get 8 over 6, which if you reduce, you get 4/3. So your constant of variation is 4/3. And if you really wanted to, you could write the equation. It's going to be y equals 4/3